In this video, you'll learn how to identify the domain of a function given a graph, an equation, or a situation. The domain of a function is all possible input values. A restricted domain means that not all numbers are possible input values. How can you find the domain of a function? When a given function is in graphical form, use the graph to determine all possible input values. On an xy plane, input values are x values. For example, the graph of the function y equals x squared plus 1 is a parabola passing through the point 0, 1. Looking at the graph, any x value can be an input value for the function, so the domain is all real numbers. As another example, let's draw the graph of y equals the square root of the quantity x plus 1. Looking at the graph, possible input values for the function are real numbers greater than or equal to negative 1. So the domain is x is greater than or equal to negative 1. Sometimes it might be easier to find values where the function is not defined. For example, let's draw the graph of y equals 1 over x, which has two branches, one through the point 1, 1, and the other through the point negative 1, negative 1. Looking at the graph, we can see that the function is not defined when x equals 0. So the domain is all real numbers. X does not equal 0. When given an equation, use knowledge about function types to determine the domain. All linear, quadratic, and all higher degree polynomial functions have a domain of all real numbers. For exponential functions, the domain is also all real numbers. For rational functions, division by 0 is not allowed, so the domain is all real numbers for which the denominator is not equal to 0. For square root functions, the quantity underneath the radical cannot be negative, so the domain is all real numbers for which the radicand is greater than or equal to 0. When given a verbal situation, first determine what variable constitutes the input values, then determine all possible input values. Some questions you might want to consider are, can input values be negative? Can input values be fractional values? Are input values restricted to a certain interval? Let's look at an example. The graph of a function is shown. Determine the domain of the function. The graph shows that the function is not defined for the input value of 2, nor for the input value of negative 2. So the domain of the function is x does not equal plus or minus 2. Let's look at another example. Match each function with its domain. We'll start with the first function. This function is a rational function, which is not defined when the denominator is 0. Setting the denominator equal to 0 gives x squared minus 1 equals 0. Adding 1 to both sides results in x squared equals 1. And taking the square root of both sides gives x equals plus or minus 1. Therefore, the function is undefined when x equals plus or minus 1. So the domain of the function is x does not equal plus or minus 1. Let's look at the second function. This function is also a rational function, so setting the denominator equal to 0 gives 3 times the quantity x minus 1 equals 0. Dividing by 3 on both sides of the equation gives x minus 1 equals 0, and adding 1 to both sides gives x equals 1. So the function is undefined when x equals 1. So the domain of the function is x does not equal 1. Now let's look at the third function. This function is an exponential function and is defined for all real numbers. So the domain of the function is all real numbers. Let's look at the last function. This function is a radical function, which is defined only when the radicand is greater than or equal to 0. So 3 times the quantity x minus 1 must be greater than or equal to 0. Dividing both sides of the inequality by 3 gives x minus 1 is greater than or equal to 0. And adding 1 to both sides gives x is greater than or equal to 1. So the function is defined only when x is greater than or equal to 1. So the domain of the function is x is greater than or equal to 1. Let's look at one last example. A function gives the total number of cookies given the number of boxes of cookies. What is the domain of the function? First, which variable represents the input values? The input values are the numbers of boxes of cookies. The number of boxes of cookies cannot be negative, so the domain is restricted to non-negative values. The number of boxes of cookies cannot be a fractional value, so the domain must be all whole numbers. Now you know how to identify the domain of a function given a graph, an equation, or a situation. Thanks for watching.